Let's talk about the fantastic four, that wonderful number four. One of the most interesting things about the number four is 2 times 2 is equal to 4. I know it sounds a little bit boring, but there's a lot packed in there. So, in particular, if we rewrite this, we can write 2 squared is equal to 4. And if you ignore 0 squared and 1 squared, which are trivial, 2 squared, or 4, is the first perfect square. That word square that we use when we talk about the 4 is very specific. It comes from the Greeks, who are the ones who came up with that idea. Now, the Greeks, of course, were really big into geometry. We all remember all the triangles and this and that and the other. When they looked at the number 4, what they saw was a nice little square. Oh, that doesn't look terribly squarish, does it? Should we try again? There we go. Let's just kind of cancel that one out. Okay, so they saw a square and they said, okay, 4 things. We're going to call this a square. So a number that times itself is called a square, a perfect square. And when we look at perfect squares, we're going to start off by kind of going through a couple of them. There's a few ways we can think about perfect squares. We can visualize them with dots. So I'm going to put one dot here. And this is the number 1, which can be written as 1 times 1 or 1 squared. If we go to the next perfect square, we are going to have 4 dots. So this is the number 4. And one of the ways that we can think about this, and I'm going to pop this in here, and you may have seen this before, but maybe you haven't, is we're going to take and make these into little squares. So notice our first square has 1 dot in it. And when we expand our perfect square, we get 3 more dots. So this is 1 plus 3. Oh, isn't that lovely? Okay, we also know that we can write this as 2 times 2 or 2 squared. Okay, what happens when we go to the next perfect square? Our perfect square from a geometrical standpoint. So, right, we're going to go to that Greek geometry. We're going to make this a little bit bigger. And let's look at our squares again. We've got our square with 1, 2, and then we get our little bigger one. All of a sudden, we have the number 9. And you'll notice that we can also write this as 1 plus 3 plus 5. So, and I forgot to write in here, our 1 down here is just 1. So we're not adding anything there. Now, we're adding odd numbers to get our perfect squares. This is also 3 times 3, which is 3 squared. Let's do one more. We're going to get one bigger. So we're going to make slightly bigger square here. And this is going to give us 16. And we can draw in our little squares here. You'll notice that this time we start off with 1 plus 3 plus 5. And if we go along this outer row right here, there are 7 dots that we added. So when you're working with perfect squares, you can also think of it as adding the odd numbers together, which is really cool. Numbers are fascinating. So that gives us 4 squared. And this keeps on going, right? So you'll notice that for every number out there, we have a square that we can associate with, right? We start with 1, 2, 3, 4. We skip 0 because 0 squared is equal to 0, and nobody really cares about that. So I'm going to write these down as a list. Let's go to the next page. We are going to have 1, 2. This time I'm going to put 0 on there. I know it's not that important. 0 squared, 1 squared, 2 squared, 3 squared, 4 squared. 16, 9, 4, 1, 0. And you'll notice that these lists, both of them go on forever and ever and ever. And for each number, we can find a corresponding perfect square. This actually was looked at, this sort of a problem was looked at by Galileo, the astronomer. We always think of him as an astronomer, that's what he's known for, but he also dabbled in mathematics a little bit, and he looked at numbers like this, and he said, okay, wait a second, this first list, which is of the natural numbers, that's what we call them, are infinite, right? There's infinitely many of them. Right? It never stops. It just keeps on going. The second list of our perfect squares, well, that's sure interesting. That is also an infinite list. It keeps on going forever and ever and ever. Both these lists are infinite. And if we write our first list out, and I'm just going to go up and do a few more numbers. And we're going to highlight our perfect squares, 0, 1, let's see, 2 squared is 4, 3 squared is 9. Those are our perfect squares. We'll notice that there are more natural numbers than there are perfect squares. But Galileo looked at that and said, is that really true? What do we mean when we say more? Is that going to be actually the case? When we look at this, he found out that when you have this correspondence, right, this thing right here is called a one-to-one correspondence. So we usually do a 1-1 to say one-to-one. These two lists technically have the same number of items in them. In other words, it doesn't matter which you're looking at, which list you're looking at, you can always find a corresponding number. So there have to be the same number of things in both lists. Number of objects or things. And this is quite the solution, right? Notice one of them looks like they have more things in them, but they actually don't. It is the same number of objects in each list. And this starts to get us into some of the contradictions and what's the word? Things that happen when you start talking about infinity that don't quite fit with the way that we want to think about infinity. We can't always follow our natural intuition when infinities are involved because infinity is such an odd thing. It is not something that we naturally think about. I'll leave you with this thought. Infinities weren't actually dived into deeply into the 1900s. That's when a lot of the work went on with infinities, how they worked, the different ways to talk about them, and how to describe the size of different infinities, because there are different sizes to infinity. So there's some weird stuff that goes on. All of this started with the little Fantastic Four. If you'd like to hear more about numbers and such, please hit subscribe so that you don't miss the next video.